All right, hello. Um, we are covering 4.1, part 1 in this video. I break up 4.1, which is graphing, into 5 parts because I like to go over each graph one at a time. So you will have a video for the sine graph, another one for cosine, another video for tangent, and then a fourth video for the other 3. And then the 5th video, which will cover odd and even functions. Okay, so let's begin. Take notes. Hopefully you checked in for attendance. 4.1 basic graphs. And we're going to start with the sine graph. Okay, so basic sine graph. So what we're doing here in chapter 4 is we're going to be looking at all the different graphs. So here in 4.1, we just start off with the most basic equation. So we start off with just y equals sine x, as opposed to, you don't have to copy this down, but as opposed to something that looks more like this. So we work our way up to things like this, 1/2 sine 2x minus pi. So this is much more complex, but what we do here in chapter 4 is we build up to this. So we start adding one little piece at a time. We don't attack the whole thing at once. Okay, so we first start off with this very basic sine equation. Y equals sine x, nothing added, subtracted, multiplied, divided. Okay, so just y equals sine x. Okay, so let's take a look at a table of values. Most of the time you guys do a table of values like this, but here I'm going to go horizontally instead. Okay. And we'll make a nice long table of values. Do we normally graph like this? No, but I'm going to make a table of values here so that you can see where the points are coming from. Okay. And then when we do graph, we don't really make a table of values. We just look at the equation and we do the necessary adjustments. All right. So let's do 0. We're going to look at 0. Of the 3 degrees between 0 and 90, like 30, 45, and 60, I like 30 because sine of 30 is 1/2. So I'm going to use pi over 6. Okay. Pi over 6. And then we'll look at 90 degrees, which is pi. And then the one that has reference angle 30, so 150. 150 is what? 5 pi over 6. And then, not pi over 2. So make sure you fix this. Okay, so 0, and then the angle 30, that's in quadrant 1, and then 90 degrees, and then the angle in quadrant 2 with 30 degrees reference angle, and then pi, and then the angle in quadrant 3 that has reference angle 30, so that is going to be 7 pi over 6. Okay. And then 3 pi over 2, and then 2 pi. Well, actually, 11 pi over 6, and then 2 pi. All right, so let's take a look at all of these here and see what we get. All right, so sine of 0 is 0. Sine of pi over 6 is 1/2. That's why we chose pi over 6 as opposed to pi over 4 or pi over 3. Okay, when we do cosine, then we'll choose 60 degrees since cosine of 60 is 1/2. Okay, but for now we're doing sine, so we'll use pi over 6 because we're doing this without a calculator, or at least I do. Okay, sine of pi over 2 is 1. And then 5 pi over 6 is 1/2. Sine of pi is 0. and then 7 pi over 6 is negative 1/2, and then 3 pi over 2 is negative 1, and then 11 pi over 6 is negative 1/2, and then 2 pi, we're back to 0. Okay, so when we graph, I don't even use the pi over 6s here. So I pretty much just use 0, the ones where we get 0, 1, 0, negative 1, 0. Okay, but I am including all of these, the ones where you get 1/2, just so you can see. Okay. All right, so when we graph this, that's our y-axis. This is our x-axis. And we go from 0 to 2 pi. Halfway in between is pi. And then halfway in between here is pi over 2. And halfway in between here is 3 pi over 2, right? Okay. And then we go as high as 1 and as low as negative 1. All right, so we see we get 0, and then at pi over 2 we get 1. Pi we get 0. 3 pi over 2 we get negative 1. And then 2 pi we get 0 again. All right, you're like, why did I skip the pi over 6s? Okay, let's throw those in then. Pi over 6, which is like 30 degrees. So about 1/2, not about, but it's 1/2, so right there. And then 5 pi over 6 is also 1/2, so right around there. And actually, 5 pi over 6 is closer to pi. And then what's after 5? 7 pi over 6, closer to pi as well. And we're at 1/2. And then 11 pi over 6, closer to 2 pi, which is 1/2. Okay, and so here now you can kind of see the wave function that is developing here, but you could see that without the 1/2s that I was just plotting. But this is basically the graph of sine. So it has this shape. Okay, and if we were to continue going beyond 2 pi, like let's say we're going to go to 4 pi, right? Well, we know that everything starts to repeat because all of these angles would be coterminal. All the angles after 2 pi would be coterminal with these angles over here, right? So even if we decide to go to 4 pi, this exact same graph, here I'll use a different color, this exact same graph would continue if I decided to go to 4 pi, right? And all the way down here. This graph would repeat. Okay, so it would repeat itself. If I wanted to go to 6 pi down that way, then it would continue. This wave function would continue over that way. My screen is small, so I can't go beyond this edge here. Okay, but same thing with this direction. Okay, if I decide to go to negative 2 pi, right? Then I would get the exact same sine wave. So I would get 0 there, 0 there. It's already 0 there. Halfway between 1, halfway between negative 1, right? I would get this same graph. Okay, so here, instead of just doing this forever and ever nonstop, we can just graph this one wave right here. This is considered one cycle. We can graph one cycle of the sine wave, and we would understand that it would repeat. Okay. All right. So let's go ahead. But one of the things that you want to take note of is the fact that, okay, when we have this sine graph, we know that we have 0 at the endpoints and 0 in the middle. And then halfway between here, we have 1. And then halfway between here, we have -1. Okay, so that's kind of what you want to remember as to help guide you when graphing a sine function, especially when they get more complicated. When they get more complicated, you still start off with this basic sine graph, and then you start doing, you start manipulating this curve here according to all of those numbers that are being added, subtracted, multiplied to sine. Okay, so but you always start off with this basic sine graph. Okay, so it's very important that you remember the shape of the sine graph from 0 to 2 pi. Okay, 0 to 2 pi is where we get one full sine graph, and 0 on the endpoints and halfway in between, right? 0 on the endpoints, and 0 halfway in between. And then halfway between here, you get 1. Halfway between here, you get -1. Okay, so let's write those down. Okay, so in general, okay, so in general, y equals sine x has a graph that looks like this. Okay, and these are kind of like the 5 basic points of the sine graph that you kind of have to remember. So the y equals sine x has a graph that looks like this, and where you have 0 at the endpoints. The endpoints, this is the left end, this is the right end. So they have 0 at the endpoints and halfway in between. And we see that here, 0 on the endpoints and halfway in between. Okay. The other thing to notice is that it has +1 halfway between first two zeros. Here, let's just say this. You get +1 halfway between on the left. We see that here. Okay, so halfway between on the left, we have +1. And then we get -1 halfway between on the right. Okay, so halfway between on the right, halfway between, we get -1. Okay. And we already know that these here, this is the maximum and this is the minimum. Okay, and then we know that the values repeat. Values repeat after 2 pi. Okay, and we see that here with this graph. We did one full cycle from 0 to 2 pi, and then after that, it repeats itself. You get that same wave, 0 on the endpoints and halfway in between. And the first half in between, it's +1, and then on the right, it's -1. Okay, so the period So two things that will come up when graphing is the period and the amplitude. So the period, so let's talk about what that is first. Okay, so for any function, y equals f of x, the smallest positive number p for which f of x plus p equals f of x for all x in the domain of f is the period. What does this mean? Okay, so isn't it? I always think it's interesting when we're able to read something but then not understand what we just read. Okay, so what does this mean? So this means what I was just talking about when it starts to repeat. So over here, let's go back to that graph. Oh, let's go here. So here it says values repeat after 2 pi, right? And we see here that, okay, so then like right over here, what is that? So since we're going by halves, 1 half, 2 halves, 3 halves, 4 halves. So this is 5 halves, right? So this is 5 halves right here. So right here, we see that they are equivalent. So if you just add 2 pi to this, you'll get the same y value. If you add 2 pi to this, you'll get the same y value. If you add 2 pi to this, 3 halves pi, right, to this x value, go down 2 pi, you'll get the same y value. Okay, so that's what it means. When you look at this y value, which is 0, if you go down 2 pi, you'll get the same thing. Go down 2 pi, you'll get the same. Go down 2 pi, you'll get the same. Same thing here. If you go down 2 pi, you'll get the same. If you go down 2 pi, you'll get the same. So over here, that's what they mean. If there's some number here where you shift that much over, you'll still get that same y value. Okay, so that's what that p represents. Okay, so here, for y equals so here, for y equals sine x, the period p is 2 pi. Because if you shift over 2 pi, you're going to get the same y value. Okay. All right. The amplitude. So here, if the greatest value of y is m, and the least value of y is, we'll use lowercase m, is m, then the amplitude of the graph of y is defined to be a equals 1/2 times the absolute value of m minus m. Okay, so let's take a look at an example. So here we know that y equals sine x. We know that the maximum, the greatest value, okay, so capital M, is 1. And we know the smallest value, lowercase m, is -1, right? So if we wanted to find the amplitude, then we could go ahead and use this formula, 1/2, 1 minus -1, right? You take the difference, between the two values and divide by 2. All right, so 1/2, so that's 1 plus 1, and we get here 1/2 times the absolute value of 2. So that's 1/2 times 2, and that will give us 1. So the amplitude for y equals sine x is 1. Okay? All right, and then the zeros. You may remember what a zero is from your previous math class. So let's just quickly review what it means. So a zero of a function, like remember when you had to, when you were like graphing polynomials, you had to find all the zeros, all the real zeros, right? Okay, so a zero of a function is any value c such that, in the domain. Okay, so any value c in the domain of f such that f of c equals 0. Okay. Also, C0 will be an x-intercept. Okay, so if you remember doing graphing polynomials, when they say find all the zeros, that's basically you're solving the polynomial. You're trying to figure out when that equation equals 0, okay? When that function equals 0. And wherever you have a 0, that's where you have an x-intercept, okay? So for example, with sine, we have y equals sine x. And so we like to know, when does this function equal 0? And that would be whenever x is 0, pi, 2 pi. And we can keep going, right? We could keep going because 2 pi is coterminal with 0, and we can keep going and going and going. Okay, so so we know that when we graph, we see that at 0, pi, and 2 pi, that's also where we have x-intercepts. Okay, so that's what they're saying here. Zeros of a function are also the x-intercepts. Okay. All right, so that's it for part 1. So that's how you graph sine function, basic sine function. Okay, so in the next one, we are going to take a look at how to graph cosine. All right, I will see you in the next one.